Beneath the Swiss-French border, the world's most powerful machine is unlocking secrets that could reshape reality itself. Did you know the Large Hadron Collider at CERN can recreate conditions a fraction of a second after the Big Bang? That's not just science fiction, it's happening right now, revealing mysteries that have puzzled humanity for centuries. Here's a punchline. Scientists once set out to create a black hole in the lab. Sounds wild, right? But do you know what really happened when they tried? The big experiment. Deep beneath the border of Switzerland and France, a machine hums with the energy of 1 billion lightning bolts. The Large Hadron Collider at CERN isn't just another scientific tool, it's the world's most ambitious experiment, designed to answer the deepest mysteries of our universe. Here, scientists accelerate tiny protons to speeds just shy of light itself, then smash them together in a controlled chaos that recreates conditions from the dawn of time. The stakes? Nothing less than rewriting what we know about reality. When the LHC first powered up, the world held its breath. What secrets would these collisions unlock? Could they reveal hidden dimensions, new particles, or even the birth of a black hole right here on Earth? The excitement in the scientific community was electric, matched only by the curiosity, and sometimes fear, of the public. For the researchers, each collision was a chance to glimpse the unknown, to catch a fleeting signal that could change everything. The LHC's detectors, massive and intricate, waited to capture every trace of the subatomic fireworks. Every second, data poured in, flashes of energy, trails of particles, whispers from the fabric of the cosmos itself. This wasn't just about smashing atoms, it was about pushing the boundaries of human knowledge. The world's brightest minds gathered at CERN, united by one goal, to unlock the secrets of existence, one collision at a time. And on that day, as the LHC roared to life, the stage was set for a discovery that could shake the universe. The black hole theory. Rumors swirled as whispers of black holes at CERN hit headlines, sparking debates from classrooms to coffee shops. The idea wasn't science fiction, it was rooted in real physics. Some theorists proposed that the extreme energies inside the Large Hadron Collider could momentarily create microscopic black holes, so tiny they'd vanish in a flash. These wouldn't be the monstrous cosmic beasts devouring stars, but subatomic blips, lasting less than a heartbeat. The theory was electrifying. If these mini black holes appeared, they could offer clues about hidden dimensions and the true nature of gravity. For physicists, the possibility was a golden ticket to test ideas that had only existed on chalkboards and in computer simulations. The world's media, though, latched onto the word black hole with a mix of fascination and fear. Headlines warned of doomsday scenarios while scientists calmly explained the math. Any black hole produced would evaporate instantly, harmlessly, thanks to a process called Hawking radiation. Still, the buzz was unstoppable. People wanted to know, could humanity really create a black hole, even for a split second? The tension between groundbreaking discovery and public anxiety gave the experiment an edge of drama rarely seen in science. As the countdown to the first collisions ticked down, all eyes were on CERN, waiting to see if the wildest theories in physics would leap from the pages of textbooks into reality, even if only for the briefest moment. Public panic. The world watched with a mix of awe and anxiety, as news outlets ran wild with headlines about CERN potentially creating a black hole. Social media feeds exploded with speculation, fueling a frenzy that reached far beyond the walls of any laboratory. Parents worried about their children's future, conspiracy theorists spun tales of impending doom, and even some scientists found themselves fielding questions from concerned friends and family. Petitions began circulating online, gathering thousands of signatures from people demanding the experiment be stopped. Lawsuits were filed in international courts, arguing that humanity was on the brink of unleashing a catastrophe it couldn't control. The debate wasn't just confined to science journals, it became dinner-table conversation, late-night talk show fodder, and the subject of heated arguments on radio and TV. The tension was palpable, and for many, the line between scientific possibility and science fiction seemed to blur. Yet, amid the chaos, CERN's researchers remained focused, determined to separate fact from fear. They addressed the public's concerns head-on, holding press conferences and releasing detailed safety reports. Their message was clear, the science was solid, and the risks were virtually non-existent. But the spectacle of public panic had already taken on a life of its own, transforming a groundbreaking scientific endeavor into a global drama. As the countdown to the first collisions continued, the world held its breath, gripped by a mixture of curiosity, skepticism, and a dash of existential dread. The science behind it. Physicists at CERN knew the stakes were high, not just for science, but honestly, for public trust as well. As the world's attention zeroed in on the collider, experts really stepped up to explain the real science behind the headlines. The idea of creating a black hole in the lab was rooted in advanced theories, but the reality was, well, far less dramatic than the doomsday scenario suggested. According to the mathematics of Stephen Hawking, any microscopic black hole that might form would evaporate in a fraction of a second, releasing its energy harmlessly back into the universe. This process, known as Hawking radiation, meant that even if the collider succeeded in producing these elusive objects, they'd vanish before they could do anything at all. Scientists published extensive safety reviews, showing that cosmic rays, natural high-energy particles from space, strike Earth's atmosphere with far more energy than anything produced at CERN, and have been doing so for billions of years without any catastrophic consequences. The reassurance didn't stop the questions, but it did offer a foundation of calm in the midst of the storm. Researchers used every tool at their disposal, public lectures, interviews, and open days at the laboratory, to demystify their work and invite the public into the process. Their message was consistent. The quest for knowledge is never without risk, but the safeguards were robust, and the science was sound. For those who listened, the fear began to fade, replaced by a sense of wonder at the boldness of human curiosity. The moment of truth. Pressure built inside the control room as the countdown ticked closer to zero. Every scientist glued to their monitors, every eye scanning for the slightest anomaly. The world outside buzzed with anticipation, but inside CERN, focus was absolute. Years of planning, debate, and preparation all led to this moment. The first high-energy collision inside the Large Hadron Collider. Protons, accelerated to near light speed, hurtled toward each other in a tunnel colder than deep space. The instant they collided, a burst of energy erupted, brief, brilliant, and packed with the potential to reveal the universe's hidden layers. Detectors as tall as buildings and packed with cutting-edge technology snapped into action, capturing every trace, every spark, every whisper of something extraordinary. Scientists watched the data stream in, looking for any sign, a deviation, a flash, a particle signature that might hint at the creation of a microscopic black hole. The tension was electric, every second stretching into eternity as the world waited for news. Would the experiment confirm decades of theory, or rewrite the rules of physics altogether? The stakes were enormous, not just for the researchers but for everyone watching. In that instant, the boundaries between fear and fascination blurred, and the pursuit of knowledge took center stage. The world was about to find out if the universe would reveal one of its greatest secrets, or if the mysteries would remain just out of reach. What the detectors saw. A surge of anticipation swept through the data centers as the first collisions unfolded, unleashing a torrent of information that only the most advanced detectors on Earth could decode. Scientists huddled around screens, eyes darting between streams of numbers and vivid bursts of color, each one a potential clue to something extraordinary. The detectors, engineered to capture the faintest traces of subatomic chaos, registered a symphony of particles and energy signatures. Flashes of exotic matter, fleeting and rare, danced across the monitors, each event meticulously catalogued and analyzed. But among the fireworks of quantum debris, there was no sign of a stable black hole, no gravitational anomaly, no runaway reaction. Instead, the readings matched the predictions: bursts of energy, showers of particles, but nothing that threatened to spiral out of control. The absence of disaster was, in itself, a triumph. Every blip and spike in the data told a story, confirming that the universe's rules held firm, even under the most extreme conditions humans could create. The experiment's outcome reassured not just the scientists, but a world that had been holding its breath. As the data poured in, it became clear that the LHC was not a harbinger of doom, but a gateway to deeper understanding. The detectors had witnessed the universe at its most fundamental, and what they saw was both expected and astonishing, a testament to the power of human curiosity and the precision of modern science. The unexpected discovery. What truly stunned the scientific community wasn't the arrival of a black hole, but rather the treasure trove of rare particle interactions that emerged from the chaos. As the detectors sifted through trillions of collisions, They began to reveal patterns and phenomena that had never been observed before. Among the swirling clouds of subatomic debris, researchers spotted fleeting traces of particles predicted by theory but never caught in action. Exotic combinations that pushed the boundaries of quantum physics. These discoveries weren't just statistical blips, they were windows into realms of matter and energy that had only existed in equations and speculation. Every new interaction, every anomalous signal, became a potential breakthrough, sparking debates and excitement across the globe. The LHC's ability to recreate these extreme conditions allowed scientists to probe the very fabric of reality, inching closer to answers about the universe's most profound mysteries. The unexpected findings fueled a surge of innovation, inspiring new experiments and theories that rippled through the world of physics. For the researchers at CERN, each surprise in the data was a reminder that the universe still held secrets waiting to be uncovered. The absence of a black hole didn't mean disappointment. Instead, it marked the beginning of a new chapter in discovery, where the unknown beckoned with even greater promise and wonder. Media frenzy. Wow, what a whirlwind it was! Newsrooms scrambled to keep up as the story of CERN's black hole experiment exploded across headlines, turning a scientific milestone into a global sensation. The media, always hungry for drama, seized on every possibility. Some outlets painted the experiment as a bold leap for humanity, while others stoked fears with talk of doomsday scenarios and runaway black holes. Social media platforms became battlegrounds of opinion, with hashtags trending worldwide and heated debates erupting in comment sections. Scientists suddenly found themselves thrust into the spotlight, fielding interviews and answering rapid-fire questions from reporters eager for a soundbite. The narrative shifted almost hourly, swinging between awe at the scale of human achievement and anxiety over the unknown. For many viewers, the spectacle was irresistible, a real-life science thriller unfolding in real time, with the fate of the planet seemingly hanging in the balance. Yet behind the scenes, researchers worked tirelessly to cut through the noise, offering clear explanations and sharing real-time updates to keep the facts front and center. Their transparency helped calm the storm, but the media frenzy had already cemented CERN's experiment as one of the most talked-about scientific events of the decade. The world was hooked, not just on the possibility of black holes, but on the drama, the debate, and the sheer audacity of exploring the universe's deepest mysteries. Scientific legacy. And so, long after the first collisions, the true legacy of CERN's bold experiment began to take shape, not in disaster, but in the seismic shift it sparked across the scientific world. The fears of black hole catastrophes faded into the background as the LHC's results fueled a new era of discovery. Among its greatest triumphs was the confirmation of the Higgs boson, the elusive God particle that gave mass to everything in the universe. This breakthrough alone redefined the boundaries of particle physics and earned a Nobel Prize, but the impact didn't stop there. The data collected from the collider's experiments opened doors to questions about dark matter, antimatter, and the very forces that hold the cosmos together. Researchers across the globe dove into the treasure trove of findings, designing new experiments and refining theories that had been debated for decades. The LHC became a symbol of what humanity could achieve when curiosity and collaboration took center stage. Its experiments not only silenced the doomsayers, they inspired a new generation of scientists, engineers and dreamers to push further and dig deeper. The legacy of CERN's black hole quest is written not in fear, but in the relentless pursuit of knowledge and the breakthroughs that continue to ripple through the world of science, reshaping our understanding of the universe with every passing year. The ongoing quest. But curiosity refuses to rest, and at CERN, the quest for answers only grows more ambitious with every passing year. The Large Hadron Collider, once the subject of global suspense, now stands as a launchpad for even bolder experiments. Researchers are ramping up the energy, refining their detectors and dreaming bigger than ever, hoping to uncover new particles, forces, or perhaps even cracks in the very laws of physics. Each experiment is a leap into the unknown, a calculated risk that could unlock secrets about dark matter, quantum realms, or the origins of the universe itself. The excitement in the halls of CERN is contagious, fueled by the knowledge that every breakthrough, no matter how small, brings humanity closer to understanding the fabric of reality. The world watches with anticipation, eager for the next headline, the next discovery that could reshape textbooks and challenge what we think we know. For the scientists, the journey is as thrilling as the destination, a relentless pursuit of knowledge that transforms fear into fascination and speculation into science. The story of CERN's black hole experiment isn't over. It's just the opening chapter in a saga of exploration that promises to keep pushing the boundaries of what's possible, inspiring curiosity and wonder in generations yet to come. Thanks for joining me on this wild journey into the mysteries of CERN and black holes. If you enjoyed exploring the unknown with Space Facts, make sure to hit that subscribe button and ring the bell icon so you never miss our next cosmic adventure. I'd love to hear your thoughts. Drop a comment below and let me know what space fact blew your mind today. Your support helps us keep bringing you the universe's most fascinating secrets. Until next time, keep looking up and stay curious.